We are reviewing our quadratics. Here, this video is suitable really for anyone reviewing how to read the sketch of a parabola. It's not necessarily suitable for a grade 10 student who is just getting introduced to a parabola, but a grade 10 student who is looking at going back and reviewing it, say for an exam at the end of the semester. Great idea. Our prerequisite skills. You need to make sure, if you're handling this video, you need to make sure you're comfortable with a Cartesian coordinate system. If you're not sure, that was a very quick video, just the last one posted. Now, our quadratic. The quadratic that we're looking for, all quadratics will be sketched on a Cartesian plane. That's a horizontal x-axis and a vertical y-axis. Mine are labeled. Labeling them is a great idea. Ideally, your axes have arrows on the ends to show that, hey, these axes reach forever. Right? All the way to negative infinity, all the way to positive infinity, they never stop. We have, hopefully, we're showing the part of the Cartesian plane that we care about. Now, the parabola itself is this curved piece, right? So it starts here, and you see those arrows on the end? That means, again, it goes forever. So this parabola would reach up forever. Really, it would reach, this arrow is not just pointing straight up. It's pointing straight up and a little bit left. So this will go left forever and up forever from that arrow. And over here, it's pointing up and a little bit right. That'll go up forever and right forever at that arrow. So that means that this parabola does, in fact, go up forever. It goes left forever. It goes right forever. It does not go down forever. All right, so we will use some of that logic as we read through. We're practicing reading these parabolas, getting information from them sketched on a Cartesian plane. When we're reading a parabola, we will, hopefully, get used to reading a parabola from left to right. We're always reading it from left to right to see what it does. If that's the case, if we're reading it from left to right, then we could say that this parabola goes down, and then it flattens out, and then it goes up. We can only say that because we're reading it from left to right. Always in the future, you will be reading your different shapes from left to right. Now, this parabola has some key interesting points. They're not necessarily labeled here. That's okay. We're just practicing finding them. You'll see them labeled after a little bit of practice. The key points that we're looking at. Number one, we have the vertex. The vertex can be given as x and y coordinates, and that is the location on your parabola where it goes from decreasing to increasing, where it goes from going down to going up, or really it's going to be the lowest, or in some cases the highest point that your parabola ever reaches. Remember, we were just talking about how our parabola reaches to the left forever, it reaches up forever, it reaches to the right forever. It does not reach down forever. If it does not reach down forever and it exists, then it must have a lowest point that it reaches. That lowest point is our vertex. All right, sometimes it's the highest point depending on the direction your parabola is facing, but that's our vertex. It's given by an x and a y coordinate. Now the other pieces we are looking for. We're looking, number one, for our x-intercepts. These can also be called your roots. They can also be called zeros. They can, in some cases, be also called your solutions. Now, these x-intercepts are where your Cartesian plane, where your x-axis meets your parabola, right? So our parabola is here in blue, our Cartesian plane is there in yellow. Those green spots that come from the blue and the yellow meeting, those are the roots. That's what these arrows are pointing to. Those are the x-intercepts. That's where our parabola intersects with. That's where our parabola meets. It crosses sometimes. That's where it touches our x-axis. All right? The last piece we're going to focus on in this sketch are the y-intercepts. Now, with a parabola, you will only ever have one y-intercept. All right? That's where your parabola meets, that's where your quadratic meets, that's where your curve meets your x-axis. That's right here. There's only one. If you read it from left to right, then you should be crossing that y-axis at some point. When it exists at the same time, at the same location as our y-axis, that's going to give us our y-intercept. So, we can have different kinds of parabolas. They'll all be the same shape, but they'll be in different locations. They'll be stretched, they'll be compressed, they'll be moved around, they'll be reflected sometime. Now, if our parabola, let's look at this first case here. If this parabola opens up, that's what we say, the graph opens up, because if we view the parabola as a bowl, then the opening of the bowl would be right here. We could pour things into this bowl. If it opens up, then we say it has a minimum. It has a minimum because, as we discussed, the parabola does not reach down forever. Fantastic. Let's take a look then at the other kind of parabola we can have, the kind that opens down. We know this one's opening down because if there was anything in this bowl, it's falling out right now. All right, now a parabola that opens down goes down forever, but it does not go up forever. So we say it has a maximum value that it reaches. All right, if we see these parabolas in motion, we're looking at one that opens down, we're looking at one that opens up. Now, when these are sketched on a graphing calculator, using technology, your graphing calculator will not put the necessary arrows that you need. This parabola goes on forever, it goes on forever. Our other parabola goes on forever. The parabolas that we're working with, when we're working with equations, they will go on forever. When we're working on a Cartesian plane, they will go on forever. Now let's practice finding minimums, maximum values. Well, a maximum value is going to be right at the top of a parabola, right? Because that's the highest it reaches. A minimum value will be right at the bottom of a parabola. That's the lowest it reaches. Now the value itself is going to be however high or low your parabola reaches. That is going to be related to, remember, your vertex is right at the top, and it's given by x and y coordinates. Well, we could be a little bit more picky here with these x and y coordinates if we wanted to. This, we'll look on the right first. I'm not sure why I'm going right to left, but that's okay. The coordinates given right here would be 3. Remember, we go across first for our x coordinate, and then it goes up 4. So our coordinates would be 3, 4. Now, if those are our coordinates of the vertex, the 3 tells us where we find our vertex, okay? So where are we looking when we're reading it from left to right? Well, we're going until we see the x value 3. That's right here, right? This is where we're looking. Now, how high are we looking when we're looking here? Oh, we're looking 4 up. That 4 up is how high. If that's how high, that's your maximum. So here, we would say this graph has a maximum equal to 4. Let's take a look over here. Do we have a maximum? No, because this opens up. If it opens up, it goes up forever. If it opens up, it does not go down forever. So it will have the lowest point that it can reach. That's way down here. That's our vertex. Whoops. That's our vertex. We'll need the coordinates. If we're finding the coordinates here, we can just estimate, right? It looks like we're going across 1, but we're going to the left. So don't forget, that's a -1. And then we're going down from here. We're going down 1, 2, 3, 4, 4.5 maybe. We're not sure until we reach there. So let's say -1, -4.5 are the coordinates of this vertex. If that's the case, our minimum value, remember it's a minimum because it's the lowest it reaches, is always going to be, as it was before, is always going to be the y coordinate of your vertex. In this case, we would say that the minimum is equal to -4.5. Now, if that's all well and great, what I'll ask you to do, I'll ask you to find the coordinates of the vertex for this parabola right here. And then I'll ask you to find the minimum or maximum value from that vertex. Remember, it's the y coordinate of your vertex. And then I'll ask you to find the y-intercept and the x-intercepts. All right, I encourage you pause the video here, come back and see how you did. Good, so it looks like our vertex right here, we're working with +2, remember our x value goes first, and then -8. Our minimum value, remember it's a minimum because it opens up, so it goes up forever. Our minimum value is -8. So we need to identify this as either a maximum or minimum. We need to state which one it is, so we'll need to state on its own. We're working here with a minimum equals -8, easy. Our y-intercept, that's where our graph crosses the y-axis. Sorry, that's where our parabola crosses the y-axis. We're working right here with -6. So we could say our y-intercept equals -6, easy. Our x-intercepts, that's where our parabola crosses the x-axis. It crosses twice. Our parabola crosses over here at at where our x-intercept is 6. And over here, where x-intercept is -2. We can list them here together. Our x-intercepts are 6 and -2. There we've listed everything we were looking for. I encourage you, pause the video, try out B. I'm not going to talk about it. I'm just going to show you the final answer. Good, fantastic. You can see the vertex, you can see the maximum and the x-intercepts. I'm not showing you. That's how you do it. Next, question 3. Frankly, you should be able to handle this right now. I encourage you, pause the video. I want to see you graph all of these onto the Cartesian plane. After that, see how you did, and then we'll see what we're doing with all of these points here. Good, okay, so we can see we have 1, 2, 3, 4, 5, 6, 7 points plotted. We can see all 7 points showing right here. Our 7 points, you'll notice, give us the shape of a parabola, but we don't see a parabola just yet. Because we know we're working with a parabola, we can recognize this shape. If we recognize this shape, we can connect the points. But what we're not going to do, the trap, would be to connect all of our points with straight lines. A parabola is not a collection of straight lines. A parabola is a nice, smooth, calm, relaxing curve. So it reaches forever. Because it reaches forever, what I want you to do, I want you to make sure on your sketch it goes all the way to the edge of your graph. And from there, because our graph has run out of space, because our Cartesian plane has run out of space for what we can see right now on our page, that's why we draw an arrow. It is a trap. I do not want to see you draw an arrow way down here when you have all of this empty space on your Cartesian plane. If you have space, I want to see you using it. All right, nice work. B, I want you to try all on your own. Plot onto the Cartesian plane, pause the video, see how it looks. Good, so we have all 7 of our points. Again, we recognize, hey, this is a parabola. We can connect it with a nice, smooth, calm, relaxing curve. We can draw our arrows. Don't fall into this trap. Use the space. If you have space, use it all the way down, arrows at the edge of your graph. There you are. If you followed along, hopefully you're feeling a little bit more comfortable plotting a parabola from a table of values. Hopefully you're feeling a little bit more comfortable identifying some key pieces, that is coordinates of the vertex, maximum and maximum or minimum values, your y-intercepts, and your x-intercepts. Nice work.